Muted.
Good evening, everyone. Welcome all to session 31. Okay. So last class we started the exception handling. Let us get started. Okay. Last class we started exception handling, and we will continue that topic today. Okay. So yesterday we just briefly discussed about nested try statements and other things like throws clause and finally clause. Okay. Today we will continue with this. So as we have seen, like other constructs, right? Loops, classes, interfaces, all those things, we can kind of like nest them. Similar to that one, we can nest try statements as well, try catch blocks as well. Okay. So what happens when we try to nest try catch blocks? Okay. Let us see an example and try to understand what exactly happens. Okay. So here, what are we doing? So we have one outer try block. We have outer try block, and corresponding to that outer try block, we have this particular catch block. Okay, and then we have inner try block. Corresponding to that, we have this catch block. Okay, so whenever we throw an exception here by inner try, that will be caught by this particular catch. And if at all any exception is thrown by outer try block, that will be caught by this particular catch block. Okay, let us run this program and see what exactly happens. Okay, so notice we are throwing arithmetic exception here, and this particular catch statement catches arithmetic exception. After this is done, we are throwing arithmetic exception, which will be caught by this particular catch block. Okay, so notice the output. Okay, let me try to do. Okay, so notice the output. So first time when we throw an exception, arithmetic exception, that is caught by inner catch block. So that is what is being shown here. Okay, the arithmetic exception caught by inner catch block. So it also shows what is the arithmetic exception. Okay, what exception it is, what type of exception. That is arithmetic exception. Okay, after this is done, we are again throwing arithmetic exception. Okay, that is then this particular catch block. That is this particular catch block catches it. That is this particular catch block. Okay, that is where the arithmetic exception caught. That is what is being printed here. After that, we print a particular print statement. That is also we can see here. Okay, that is also we can see here. But let us see what happens if we try to throw. Okay, we can see the array index out of bounds exception was caught by this catch statement, and this arithmetic exception is caught by the inner catch statement. Okay, let us add one more catch statement here. Okay. Okay, what did I do? I have changed this catch block. This particular catch block is catching array index out of bounds exception. Okay, so for this particular catch block, okay, this particular catch block belongs to this try block. Okay, but this particular catch block is catching array index out of bounds exception. Okay, but we are throwing arithmetic exception. Okay, which is caught by try block, outer try blocks, catch blocks, one of the catch blocks. Okay, so here we have first we have array index out of bounds exception, and then we have arithmetic exception. Okay, let us try to, but notice that we are not catching arithmetic exception inside our inner try block, try catch block. Okay, inner catch. This is not, this particular exception handler is not catching. Exception handler is not catching arithmetic exception. Okay, remember that one. Let us try to run this program. Can anyone tell what happens when we try to run this program? Can anyone tell what happens when we try to run this program? So no one knows what happens when we run this program. We are throwing arithmetic exception here, but this particular catch statement is not catching arithmetic exception. It catches only array index out of bounds exception, right? So what exactly happens when we run this program? Let us run this program and see what exactly happens. Okay. So we can see arithmetic exception is caught by outer catch block. Okay. The arithmetic exception is caught by this particular catch handler. Okay. So what is happening? This catch statement is not handling arithmetic exception. So this is thrown to outer try block. Okay. This arithmetic exception is thrown to outer try block. Then once the arithmetic exception is thrown to outer try block, these catch statements are matched. Okay. These catch statements are matched for this particular type of exception, that is arithmetic exception. This will not be matched. This particular catch block will match the type of exception thrown inside your inner try block. That is when this catch block comes into picture, and then it displays this statement. Okay. So what is happening? So if the inner try block's catch block or catch handler or exception handler is not able to handle the exception thrown inside the statements within your try block, that will be handled by the catch blocks which are mentioned outside of outer try block. Okay, this is your outer try block. This is your inner try block, right? So this inner catch block is not handling arithmetic exception. That is why these catch blocks are considered. Okay, so one of the catch blocks matches the type of exception thrown by inner try block, and this particular statement gets executed. Afterwards, the program execution continues normally. Okay, that is why we are able to see this print line statement. Okay, what happens when we when we don't have this particular block of code? Can anyone tell me what happens when we try to let us comment this part? What happens when we comment that this catch handler or exception handler? What happens when we run this program? Here we have array index out of bounds exception. Here we are throwing arithmetic exception, and here we are throwing array index out of bounds exception. Yeah, exception is correct. Exception is there, right? Okay, we are not printing the stack trace as of now. Yeah, all exceptions. Yeah, Tina is telling runtime exception. All these are runtime exceptions only, right? Whatever the exceptions that we are discussing, all are runtime exceptions, right? So all these are part of your runtime exception. We will see these are all called unchecked exceptions, and we will see why they are called unchecked exceptions. Okay. So this arithmetic exception is thrown. Is there any handler which is catching arithmetic exception? No. Let us run this program. Okay, let us run this program. That will give you some idea. Okay. Okay, what exactly happened? Kavita told stack trace. So what did happen here? Can anyone tell what happens here? And we are here now. We are not able to see this statement getting executed. So why this statement did not get executed? And what exactly happened here? Can anyone explain me? At line 12, Kavita is telling at line 12 exception happened. Correct. Then what happened? That is your arithmetic exception is thrown in inner try block. Then what happened? It is nested exception. Okay, I'll unmute you. Yeah, you can speak, Kavita. Yeah, you can speak. Instead of typing, you can speak.
Yeah, I mean, it is showing that there has been an exception which is not handled, and it shows that at line 12 the exception has occurred. That is a arithmetic exception which has to be handled.
So who? No, anyway, whether
Yeah.
the method
I mean,
handles or someone else handles. Yeah.
yeah, it is java.lang exception, arithmetic exception that has occurred.
Okay. Here. Yeah. Yeah. Go ahead. Go ahead, Kavita.
I mean, it is not cached there, so I mean, the inner exception has been thrown to outer, and there is nobody to. I mean, it is not been cached, so I mean, it has. So it is showing in the stack trace that this exception has occurred.
Okay. So that is what.
That's
No.
what.
Whenever an exception happens, that has to be caught by someone, right? That has to be caught by someone. It has to be caught by someone. So who is catching this exception here?
JVM. I mean,
Yeah, default exception handler is
JVM.
provided by JVM, right? Java provides the default exception handler. That is what caught this particular exception. That is arithmetic exception. So what is the behavior of your default exception handler? It just prints out the stack trace and then terminates the program, right? That is why this particular statement was not executed. Okay. Yeah, so that is why this particular statement was not executed and then the program got terminated. So otherwise, if we have this statement, so what exactly happens in that case? This particular catch block catches this exception, arithmetic exception, and then this statement gets under the execution of the program continues normally. So that is why this particular statement got executed, and then we are able to see this particular output after try catch block. Okay. Let us see what happens if we try this one. So in this case, what will happen? So what exactly happens? So here we are throwing arithmetic exception that is caught by this handler. and then once this is caught, we are proceeding normally. Then we are throwing array index out of bounds exception. We don't have anything to catch array index out of bounds exception. That is why default handler terminates the program. So if we remove this, part, yeah, if we remove that part, we can see the exceptions properly, right? So array index out of bounds exception is caught by the outer this one, and in the arithmetic exception is caught by this particular catch statement. Okay. So let us see what happens with the three inner blocks. Okay, we have outer block, inner block, and innermost block. Okay, in innermost block, we are throwing arithmetic exception. Here we are catching null pointer exception, array index out of bounds exception, and then arithmetic exception. Which catch block will catch this arithmetic exception? The outer. Okay. So this will be thrown to this because no catch handlers or exception handlers are there. Here also we don't have corresponding exception handler to catch this. So it goes outside, and then we see an exception handler which can handle the arithmetic exception thrown by the inner try block. The statement inside your inner try block. That is when this particular catch block handles the arithmetic exception and prints out the exception. So we are just printing out the exception. That's it, right? Yeah, correct, Kavita. Yes. So we have seen how a try block inner nested try catch blocks execute. Let us see how to throw an exception manually. Okay. So in the previous example itself, we have seen how to throw an exception. So here we use the keyword throw, and then throwable object. At the root of exception, we have throwable class. Okay, whichever the exceptions that we are discussing now, they are part of exception subclass of throwable class. Okay, exception subclass of throwable class, and then usually mention like this. Okay, and then runtime exception. Okay, assume that a particular method does not want to if some error happened and it wants to throw that error to the calling routines. Calling routines means a method which is calling that particular method. So I have method A. It doesn't want to, whatever the exception that it calls, it doesn't want to handle it. It wants to throw it to the method which calls this method. Okay, this method. So in that case, what we do, manually we are throwing the exception using the throw clause. That is what we are doing here. What are we doing here? So we are manually creating an exception. Okay, exception object. So what happens when an exception occurs or an error occurs, runtime error occurs? The JVM creates, Java runtime system creates an exception object. Java runtime system creates an exception object and then throws it inside the method in which that particular exception has occurred. Okay, here what are we doing? Instead of Java runtime system, we ourselves are creating an exception object. It is of type arithmetic exception. Okay, and then we are throwing using throw class. Yeah, Kavita, do you have any questions?
Yeah, like if there are two same exception, like in the inner exception is arithmetic exception, which is not handled, and the outer exception is also arithmetic exception. I mean,
Okay.
so I mean, if there are two same exception occurring and only one catch block is there to catch that one, so it works for both the exception, or I mean the catch block.
Yes, that is how it works. In fact, if you see here, right, throw in the previous example itself, it was evident what exactly happened.
Oh,
Arithmetic, right? Exception. Okay. So let us put some statement here. Okay. So anything like here we have not put. Okay. Let us put this also. Okay. First arithmetic exception. Let us try to print the message. Okay, we can see this. So which one was caught actually? The first arithmetic exception was caught. Okay, once a particular exception is caught, others are not at all considered. Okay, say for example, let's see here. Let us try this way. Okay, and then throw this. Let us see what happens. Okay, in this case, what happened? Here, arithmetic exception, first catch block caught the first arithmetic exception, and then we are throwing second arithmetic exception, right? And then this particular catch block caught the second arithmetic exception. Did you get what exactly is happening? Did you get what exactly is happening, Kavita?
Yeah, I mean, first the innermost exception is first caught, right? First arithmetic
Yes,
exception, then the
correct.
outer second exception. So it goes from inner to out. Yeah.
Yeah, correct. Also, when one of the exception is thrown, and if it is not able to, if it is not caught within that catch, if the inner try block does not have a corresponding catch block, it comes out of this one, and this particular catch block is checked whether the type of exception thrown by inner try block is matching this catch block. Okay, that is also not matching, so it comes here and the match is found. Okay, so this particular statement gets executed and it will be out of this whole try catch block. Okay, so this is not at all considered at that time, because already the control is out of this inner try blocks, right? So it is here. So it means like this particular object is thrown to outer block and outermost. Then we are here in this scope. So that outer try block, it has the arithmetic exception here thrown by this particular object, and it is caught here, right? And then once that exception is caught, now once that exception is caught, this particular statement gets executed. That is, your normal execution starts. Okay. Normal try catch block. Normal execution starts. So the controllers come from inner try block to outer try block, and then this particular catch block executes, and then it will not go inside again for this particular exception. Okay, it will continue with the next statement after your try catch block. It may be your outer try block or inner try block or whatever it is. It depends on what kind of handlers, what type of handlers you have for corresponding try block. Okay. So we are discussing about throw clause, right? So normally Java runtime system creates an exception and it will be thrown inside the method where that particular exception has occurred. But here what we are doing, we are manually throwing, we are manually creating an exception object. This is our exception object. This is our exception object. We are manually creating an object using new operator. Create an exception new object, and then we are throwing manually inside the method, in which we have written here. So we have only one method, that is main method. Okay, that is the main method. So this is thrown here, but we don't, as just now as we discussed, we don't have a corresponding or appropriate apt catch handler or exception handler here. So that is thrown outside of this one. So here also we don't have the catch block which handles this type of exception, that is arithmetic exception. So it comes out, and then this catch block handles the arithmetic exception. So the flow is out of the inner blocks. Okay. So now the control is here. It comes here. It prints. The control is inside your arithmetic, this particular catch block. It prints this and then comes out of try catch block, and then it prints this particular statement, and then it terminates the program. In the first, it normally what to say. So it completes the execution of this particular program. That's it. Okay. So this is the keyword that we use to throw an exception. So instead of that, we can also type like this. Okay. Throw A. Okay, that is what is the syntax we have mentioned here. So throwable object, any throwable object, that is any exception that is subclass of your exception class. Exception itself is subclass of throwable object, right? Throwable class. So that is why we can throw this using this particular syntax, whatever we have mentioned here. Okay. So it is similar to whatever we have done it. When we try to execute this program, we will get the same thing. Okay. Caught by outer cache block. What is the exception? The exception, it displays the message or the description of this exception, which is mentioned in our constructor. This is our constructor. Okay. And then next statement gets executed and the program completes. That's it. Okay. So apart from our throw class, we just tried to discuss last class in a hurry. We just had a brief discussion about these other four keywords, right? So that is why I'm trying to explain it with an example now. So throws class, we have another class called throws class. Okay, this is used when a particular method does not want to handle and throw it. We are not manually throwing it. There is a difference. There is a extra S here. So it simply means that the method, say for example, we have one method A, okay, and another method B, which is calling A method. Okay, so an exception is being thrown in this particular method. Okay, but it is not handling that exception. This is not handling this particular method is not handling that exception thrown inside this particular method. So if it wants to, this particular method wants to caution other methods who are calling, that is B in this case, to handle the exception thrown by A method. Okay. So in fact, if A wants to inform other methods who are calling this particular method to handle the exception thrown by this method. Okay. In that case, we will use, in such case scenarios, we will use throws class. Just by mentioning throws exception in our method declaration. So that is what we have mentioned here. Now, as we know, this is the return type. This is the method name. As usual, we will have parameter list, but it tells other methods who call this particular method to handle the exception thrown by this method. Okay, it says this is telling like I am throwing the exception. Whoever are calling me, please handle that exception. I am throwing this exception to you. You handle that exception. That is what this clause means. Okay, so that is why whenever we say, for example, we are so let us see an example. Okay, so whenever Okay, here we are not, this is thrown actually, this particular method is throwing exception, but it is not handling that exception. This null pointer exception is of type runtime exception, which is unchecked exception. That is why it is not showing anything here. So in this case, we can mention throw exception. Okay, it says it is throwing exception. Whoever wants to call this method, right? Though that method has to handle the exception thrown by this particular method. So when we try to use that method, now what is happening? Main method is calling throws exception method, but throws exception method is throwing an exception. Okay, so it is saying whoever is calling me, you have to handle the exception I am throwing, that is null pointer exception. So in that case, the method which is calling this method has to handle that exception. Okay, so now we are handling that exception, whatever the exception that is thrown here, right? Whatever the exception this particular method is throwing, we are handling here. Okay, so that is why it is not saying, it is not complaining as such. If we remove this try catch block, you can easily see the error, compile time error itself, right? So here you can see easily, you can see if we don't specify. Okay, okay, so now it shows exception. Okay, unhandled exception type exception. So it asks whether there are two fixes. One is add throws declaration or surround it with try catch block. Surround this particular statement with try catch block. That is what it says. Okay. So when we include that statement within try catch block, it automatically goes. And when we execute it, the execution is normal. Okay. Exception is normal. So the execution continues after this exception is caught and this particular statement gets executed and the program terminates normally, like as usual. As usual, the program completes, it completes and it stops. Execution of this particular program stops. Okay. So that is how you use throws class. And when using throws class, you have to, while declaring your method, you have to mention this particular point. Okay. Throws and then exception you can mention. Whatever the specific exception you want to mention, you can mention that as well instead of exception. Okay. Then we come to finally block. So when we were discussing in yesterday's class, we told, like, say for example, we have some network connections opened and or we have some DB connection opened, or say for example, we are reading some data from an input file. Okay. So that time an exception happens. As in, right, we are not able to connect to the network, or we are not able to connect to the DB because DB is not available. DB is down. Okay, that time an exception happens. So in that case, we would have created some objects. Whatever we talk in Java, right, they are all objects only, except your primitive data types. Okay, for connection also, you would have created some connection object. Okay, or for opening a file or closing a file, you would have. Okay, Kavita is asking a question. What is the best method? So Kavita is asking, what is the best method in catch block? What is the best practice? That is get message, e.get message. It depends on what, how many, how much, or how how detailed you want, how much detail you want. Okay. So usually, whenever you are debugging or testing, right, it is better. It is always better to have stack trace, print stack trace, right? That particular method is there, print stack trace method, which will give you the entire stack trace of your method invocation. That is the best one. Okay, while debugging. So when you, even when in production also, you can put print stack trace, but yeah, in your log file. It will be easier for you to debug if at all any error comes. But that again depends on you will set different log levels for your production environment. For your development and test environment, you can go for say printing stack trace, but that is not advisable for your production environment, because the log, as the log gets accumulated, right? That also takes some amount of time while printing this one, right? While printing that stack trace, say for example, I want to print here. Remove this, okay? So what is happening? I will just print this one. Exception is thrown, okay? And then what is happening? This particular stack trace is printed, and then we are coming here and printing the other statement, the last statement of your program. So in production, we will not consider about these things, all these things. We will just try to print this one, okay, to see whether any exception has occurred, because only for some critical exceptions, right, we will try to print the stack trace. Otherwise, normally we will not print the stack trace at all, okay. So just we will try to print the description for normal exceptions, but very critical. Assume that there is a piece of code on which the entire application depends. Okay, you should, if at all something, if at all because of that exception, if at all your application comes down, you want to fix that issue as soon as possible, right? So that is when you try to, in such scenarios or at such points, you will try to print out the stack trace, the host stack trace. Otherwise, you will not print out the stack trace. Just you will try to print this description, and you will finish. You will be done with that. But why that is done is, for printing these things also, it takes some amount of time. Maybe it is a fraction of minute or fraction of second, but that also is considered very critical. Okay, so performance matters a lot in case of production deployments. That is why we will not go for such stack traces and all in production. Okay, so if you start giving stack traces for each and every exception, right, in production, you'll have thousands and thousands of Java files and thousands of exceptions thrown in each Java file. So for each Java file, if you start printing print stack trace, that will be like whenever an exception occurs, it starts printing stack trace in log. That itself will accumulate some amount of time, right? That is why we normally in production environments, we will not go for stack trace, but that has a disadvantage. Like if any exception occurs, right, you will not be able to kind of like exactly get what exactly is the exception. You have to kind of like check out the code, production code, and try those things in your development environment, and then push the code to stage, and then to other different levels to actually identify and fix that issue. Okay, these kinds of scenarios are very common. Exception occurs in your production environment, but you're able to figure that out. What you have to do is you have to try to replicate those exceptions in your this one. What is that? In your development environment. Okay, development environment. So those kinds of issues, what happens is like we get such kind of issues as production issues. Okay, so maybe some urgent production issues or some issues which are not so critical, right? Those kinds of issues, we can take time and fix those issues. But some critical issues will be there. Such issues, what happens, like they will have a direct impact on business itself, revenue impact. Such kind of issues, we have to fix those things. And at such points, right, we will know where exactly the application might create critical issues. So in such cases, at such points only, we will try to print the stack trace. Okay. So the best practice is it depends on environment to environment. Production, no stack trace. You can just finish off with your get message. This one message. Okay. Critical points, we can try to print the print stack trace, so that you get the so that it will be helpful for you to fix the issue immediately. As soon as you see the print stack trace, you'll be able to see where exactly that particular issue is happening, and you can directly go to that file and check that line itself. So you can start analyzing from that point. and then try to fix that issue. Did I answer your question, Kavita? Okay, yeah. So that is how we use try catch and throw and throws clause, and finally we have finally block. So what we were discussing is with respect to finally block, any, say for example you have some open objects, say for example connection objects, or you have opened your file. Okay, all those things take resources. Okay, while opening a file, you'll an exception might have occur. That is like some, because of some network failure or something, the connection gets closed and exception is thrown. Okay, not connection gets closed. Say for example, you create a connection object and try to connect to the database. Okay, so database is down, but connection object still exists. Okay, that connection object will have some other things also. Say for example, statement. This is related to JDBC. I am talking about JDBC. Okay, statement object. All those things are interlinked. Okay, those objects will be taking resources. Okay, resources in the sense some memory in your physical memory, right? So we don't want them to linger around in our physical memory, because that is a waste. You can call it as a memory leak. Okay, so in order to reclaim those resources, what we do is we try to close those opened objects or connection objects, those kinds of resources inside your finally block. Okay, whether your exception is caught or not. Say for example, you have your try block. Okay, and this either you can have catch block after try block, or you can have finally block. Okay, either of them should be there. You can't leave try just without catch block or finally block. Okay, one of them should be there. Okay, to handle the exception, you should have catch block, or if you don't want to handle it, you have finally block. Okay, whether this particular exception thrown in your try block is caught or not, finally block gets executed. Okay, let's see an example. Okay, here arithmetic exception is caused at this particular point in time, right? And then what happens? We don't have any exception handler. Okay, so after try block we have finally block. Okay, let's execute this program and see what is the output. So what exactly is happening? So once this is somehow, yeah, this is the right output. This is what I was expecting. So here we come here, arithmetic exception is caused here. Okay, this causes arithmetic exception, but we don't have any exception handlers here. That is why it comes to finally block. It prints inside finally block this particular statement. It executes this particular statement. And notice that we haven't caught this exception at all, right? We haven't caught this exception at all. Okay, so we haven't caught this exception, and we came to, once that exception is thrown, we came to finally block, and this is printed, and then default handler handled that. Okay, note that this particular statement and this particular statement is not at all executed, because exception is exception occurred here. This is I mean, as soon as exception occurs, it tries to come out of try block. Either it goes to catch block. If you have catch block, that exception is caught, and then finally block is executed. If you don't have catch block, it comes to finally block, executes this, And then if we have catch block after this, can we have catch block after this? Just try whether we can have catch block after finally block and tell me in next class, okay? So after that, it will try to kind of like, if we catch, after that this particular statement gets executed. If we don't catch it, these statements get executed, because finally in any case, whether the exception is caught or even if it is not caught, finally block will get executed, okay? So assume that you have some open connections here to database, okay? Some open connections here which are not kind of like closed properly. So once a particular transaction is done, it is always advisable to close those connections, okay? It is required, okay, to close those connections. So exception happened here and you have open connections here, okay? You have open connections here, but because of this exception, assume that you are closing those exceptions here. I mean the connections here, okay? You are closing those connections here, but because of this exception, these statements will not get executed at all. So these open connections will be there in your physical memory, taking resources. That is your the memory only, okay? In such cases, what you can do, you can close those connections here. If connections are not closed, those connections here, okay? So what happens if exception is not happened here, connections are closed here, okay? Then we are coming here and we are checking whether exception connections are open or not. If connections are open, we will not close at all. We will not bother to close, and then we will print this, and then the execution continues. But if an exception occurs, here the connections are not closed, okay? So here we will check whether the connections are open or whether the connections are closed. Because connections are not closed, we will close the connection and continue as normally, okay? That is the purpose of using your finally blocks, okay? Be it your database connections, opened files while processing the files, or your network connections, whatever it is, okay? So something which has to be taken care, whether the exception is handled or not, those kinds of statements we will put in our finally block, okay? So let's see what happens when we have catch block, okay? So concentrate on these things, okay? This statement and this statement, okay? So here we are printing that message. What is the message? Divide by 0. That is arithmetic exception. So let us just try to print. Here, okay? So now it says arithmetic exception, divide by 0, okay? After exception, we are handling that exception. And then after handling that exception, that is after try block, we entered catch block, and then finally block. Finally block gets executed. That is inside finally block. Okay. After inside finally block, since we have caught the exception, since this particular catch block or exception handler has handled the exception, it will not go to default exception handler provided by Java. Okay. Since this is caught, execution continues normally and completes, the program completes it after executing this particular statement. Okay. That is the use of your finally block. So let's move on. So Java provides, let's move on to built-in exceptions. Okay. Java provides built-in exception, lot of built-in exceptions, which are part of your java.lang package. Okay. So we know that exception subclass is runtime exception. There is an important exception subclass of exception, that is your runtime exception. Okay. So what are the subclasses of runtime? Which are all subclasses of runtime exception? We call them as unchecked exceptions. Okay. There are two types of runtime exceptions. There are two types of exceptions. encoded as exceptions, that is unchecked exceptions and checked exceptions. Okay. So what are these unchecked and checked exceptions? For some exceptions, compiler will not complain. Okay, compiler will not complain. Exceptions. Okay, for unchecked exceptions, all those things. Okay, they are called as unchecked exceptions, and these are all subclasses of your runtime exception. Okay, there are some exceptions. Okay, there are some exceptions. If you don't catch them, for example, your class not found exception and illegal access exception. Okay, if you don't specify them under try catch block, or if you don't try to catch them, compiler will complain, saying like there is an exception, there is a class cast exception or class not found exception that has to be caught. This particular piece of code is generating class not found exception. You have to catch it. Okay, so it says like that, or you can throw that using throws clause. Okay, it says either you catch that using try catch block, or you throw it using your throws clause to some other person who is calling that particular method. Okay, those kinds of exceptions are called as checked exceptions. Okay, these exceptions, unchecked exceptions, compiler will not say like it will not enforce the rule to use try catch block. But in case of checked exceptions, it will say you have to catch this exception, or you specify that you are not catching this and you specify that using your throws clause. Okay, those kinds of exceptions are called as checked exceptions. Examples are class not found exception and illegal access exception. Okay, let us see such exception. Okay. Okay. And let us stop this. Okay, let us comment this part. So here we have initialized I is equal to 0 and j is equal to 40. Okay, let us do one thing. Let us take out this piece of code from here and put it here. Okay, and then comment out all these things. Okay. So here what is happening? We know that this particular piece of code generates exception, right? But we have not put this in our try catch block, right? So now compiler is telling there is some issue with this piece of code, this line of code. Okay, it shows arithmetic, it throws arithmetic exception. Okay, for that matter, let us see this one. Okay, so we know that this piece of code is throwing arithmetic exception. Okay, compiler is not telling us to or put this statement inside our try catch block. Okay, compiler is not telling. It is not enforcing us to use try catch block with respect to. Okay, sorry. It is not telling whether we want to use it or not. It is left to us. Compiler is not enforcing that. Okay, so if we remove this and this, sorry, if we remove this and this thing, still it is valid. Okay, it is not, we are not able to see any compile time errors. Okay, so compiler is not checking whether this is an exception or not. This particular exception is subclass of your runtime exception. For runtime exceptions, those kinds of exceptions are called as unchecked exceptions because compiler is not checking and enforcing us to use try catch block. Okay, but we know that it causes arithmetic exception, right? This is handled by your this one. What is that? Our default exception handler. Let us try this one. Let us try to throw. Let us see what happens. Okay, we have not put this particular class not found exception inside our try catch block, right? The compiler is checking class not found exception. Okay, it is checking and it says unhandled exception. Okay, compiler is checking whether we are catching this class not found exception or not. We are throwing this exception, right? This particular object, we are creating class not found exception object and we are throwing it inside main method. So compiler is checking whether we are handling this method is handling this exception or not. Okay, so how to handle this? Either we can put this inside our try catch block. Okay, in that case, this will be handled by this particular catch block. Or what we can do is we can mention this particular method saying throws exception. In that case also, this particular error will be removed. Okay, because compiler is checking for this exception and it enforces either use try catch block or use throws clause to mention that this particular exception either have to be caught by some other person, that is some other function which is calling this, or you yourself handle that exception. Okay, so compiler checks and lets us know how to handle that exception within that method or mention that it is thrown out of that method using throws clause. That is why these kinds of exceptions are called as checked exceptions. Okay. So built-in exceptions, we can classify them as checked exceptions or unchecked exceptions. Okay, we know what are checked exceptions. Unchecked exceptions, compiler will check and it will not complain. Okay, either throw or you catch that exception. But checked exceptions, it will check and it will let us know like you have to handle, or it will mention that someone has to handle that exception. That is why they are called as unchecked exception and checked exceptions. Excuse me. Okay. So user defined, not only built-in exceptions, we can create our own exceptions also. Okay, those are called as user defined exceptions. Excuse me. Those exceptions are needed to specify application specific exceptions. Okay, application specific exceptions. Say for example, you are trying to connect to the database. Okay, you are trying to connect to a database. Okay, and then you are querying a particular okay, it's already there. So this is data not found is not built-in exception, it is application specific exception. Okay, so when you use this data not found exception, assume that you connected to a database and trying to query a table. Okay, trying to query a table based on some filter condition which you specify in your where class. Okay, I'm not sure how many of you know about SQLs. I'm just assuming. Yeah, Kavita has mentioned. I haven't seen Kavita's comments. Yeah, compiler is complaining and compiler, yeah, compiler, when compiler complains, that is your checked exception. If compiler does not complain, that is your unchecked exception. That's what Kavita is telling. Okay, so what were we discussing? Yeah, user-defined exceptions, right? Assume that the user-defined exceptions, we use it for application-specific exceptions, okay? Most of the exceptions that are covered in java.lang are sufficient for any applications that we write. But some places we need some application-specific exceptions. Say, for example, we have connected to the database and querying a table. There may be data, there may not be data, okay? For that particular condition, for a table record, okay? Whenever data is there, we take the data and process it normally, okay? If the data is not there, we have to take care of that particular condition, saying like data is not found, okay? So I have created a particular exception, that is okay. All exceptions will have these two by default. There are other constructors also. These two constructors by default, they will have these two constructors. Okay, that's why I mentioned. So this is data not found exception. This is application specific. Okay, I will throw this exception whenever I query a database table, and if database data is not found for that particular query, which I am issuing to the database. Okay, so say for example, I am trying to okay, so here I am connecting to database. Then what I do, query process it, else throw data not found exception. So, okay, normally we will mention the query also. Okay, so we will, whenever that particular exception is thrown, right? Okay, whenever this exception is thrown, why? Okay, whenever this exception is thrown, or whenever we don't find data for a particular query, we will throw this particular exception. Otherwise, we will process it. Okay, this is application specific. We want to know when data is not found for which particular query, whatever the query that we want to, which failed, whichever the query which failed, we will mention this here in this string. Okay. So for that particular query, we can easily identify. We can run that against a database and check whether the data exists or not. So whenever we see such exception in our logs, right, application logs, we will try to check this. We will take this query, try to run that query against the database and re-verify it. That's it. Okay. In such scenarios, whenever application specific exceptions are thrown, in such scenarios, we will create user-defined exceptions for such scenarios. Okay. Say for example, you can use arithmetic exception, or you can subclass an exception for your specific arithmetic exceptions. Okay. We have, I mean, the arithmetic exception covers a lot of other exceptions also. Maybe you might come across some kind of exception which is not covered in arithmetic exception itself. In such cases, you can extend the exception class, okay, and then create your own exception class, and then use that exception class wherever you want to use, okay, wherever you want to handle that particular exception, specific exception, okay. How do we create user-defined exception? Just inherit from exception class, extend exception class, and then you need not have to do anything. Whatever the methods that we are using, like print stack trace or get message or just exception.toString method, all are taken from your throwable class. Okay, exception class does not define any method of its own. All those methods are inherited from your throwable class. Okay, but better to have at least these two, at least this one. Okay, at least this particular constructor, because we can mention the exact exception that we want to see in our logs. Okay, here we are saying this particular data not found exception is thrown with the query which is throwing that exception to the data. Okay, whatever the data we have used in that SQL query, right, that we are printing here. This will give us a clue like which particular exception or which particular data that we are using is throwing data not found exception. Okay. Anyone has any questions? Okay. So to create an exception, user-defined exception, extend the exception class, nothing to implement because everything is defined in your throwable class. Kavita, do you have an exception? So, I mean, the question you mentioned, yes. Okay. Yeah, Kavita, go ahead.
Yeah, I mean, you have written that extends exception, like, I mean, we have to use always the exception, or in some cases we can use throwable, or I mean,
yeah, you can try those things. Yeah, you try those things and let me know what happens. Okay, that is an exercise. That is an exercise. Whatever we want, we can try here itself. But try few things you try and let me know what happens, because I have not tried those things. Okay. Even if I have tried, I might have forgotten what exactly happens. Okay. Try those things and let me know. Okay. Try those things. What happens? Let us see. Okay. And whenever you are using those things, right, you have to remember the hierarchy. Okay. You have to remember the hierarchy. You have throwable, you have object, but it is good to think in those ways. Okay. You have object and then throwable. Okay. And then you have exception. Okay. Then you have your error. And then you have here important one is runtime exception. Runtime exception. Okay. It is good that you people are asking such questions. You are thinking, and when we are teaching, right, you are thinking and you are trying to think and ask those questions. It is good, but we let us try those things. Okay, let us try those things and see what exactly happens. Those are all very good points. Okay, so try those things. Try only to like not only to extend throwable. Try to extend runtime exception. Try to extend the arithmetic exception. Try to extend array index out of bounds exception. Try to extend errors also. Okay, let's see what happens. Okay, you have to try all those things. Then you will get a very good grip on all these things. Not only exceptions. If you want to get very good grip on all the topics that we have discussed, you have to try doing exercises. You have to try each and every whenever someone asks me something, right, how to understand things better, try to whatever the topics whatever the sentence that you read, whatever the sentence that you hear, right, try to put that in program. Experiment is, test it whether that is true or not. Just don't try to accept whatever I am saying. Okay, don't just try to accept it, whatever I am saying. It may be true, it may not be true. So you just have to test it whether I am telling correctly or wrong. Okay, you have to test it. If at all I am telling wrong, you have to come and tell me. So this is not I got this particular error. When this is what you told and I got error in this particular this whatever you told for this I got error. Is this true or not? Okay, those kinds of things will be like those kinds of things make our classes more interactive and more interesting also, right? So try those things and let us know. Let all of us know, Kavita. Okay, what happens? Okay. Sorry, I unmuted you.
Yeah.
So let
Yeah.
us know, Kavita. Okay. Okay.
Yeah, I will try that one. And one more thing, like we have used override sometimes when we inherit the classes, it's the override annotation comes. So I don't remember, sometimes I have seen like the warning annotation comes or something like
So like
suppress.
this override.
Yeah, suppress warning or something. I don't.
Yeah. No, that is just an annotation, just for this one. For it's a kind of like a warning. We will see these things. What exactly does that mean when we in our next class we will discuss about enumerations, auto boxing, unboxing, and then annotations. Okay. That time we will understand more about these annotations. Okay.
Yeah.
It is just like annotation. What do you mean by annotate? It is just you are trying to put, I want to annotate something to this throwable. Okay, I will just put a side note on this particular word throwable, saying like this is the subclass of object.
Okay.
Okay, I
I
just
mean, it
put the side
doesn't
note.
do anything, just it tells the user it is in that way, right? I mean, those who are
Yeah,
using
some
it.
cases it is. Yeah, some cases it is like that. But some cases, what exactly happens is, say for example, you are using application server or you are using some other framework like Spring framework or something else. Okay, in such cases, you have framework specific annotations. They will have special meanings. Means they will tell something to the application server or the framework. Okay, once a framework sees those annotations, framework will understand what has to be done for such annotation. Okay, behind the scenes there will be some piece of code which will handle those things. Okay, we will discuss all those things. We will discuss all those things in when we discuss about annotations. Okay, that is an interesting point. That is an interesting topic also. Okay, there are couple of other topics which are very interesting. One is generics and another one is these annotations. And generics, when you use extensively in util package. Okay, when we start discussing about collections. Okay, generics will become very critical in that particular topic. But annotations is used everywhere globally. Whoever is creating a new framework, they will provide annotations for such that framework. So that will become kind of like very interesting and important topic for us. We will discuss all those things when we discuss about annotations. Okay, which what exactly, whether we will be able to create annotations ourselves, and what will be the importance or what happens when we try to use those annotations, when we use annotations which we ourselves have created, those kinds of things, right? We will see when we discuss about annotations. Okay. So that's override, right? Yeah, at the rate override is just like a side note to us, saying like this is an overridden method. That's it. That is generated by your IDE. Okay, that is generated by your IDE. IDE, as soon as it sees that you are implementing an interface, or you are trying to provide an implementation to your abstract class, or you are trying to override a superclass's method, that is when it annotates that particular method with override. Okay, that is what it means. That's it. Okay. Okay. We will see the importance, all those importance in annotations class. Okay. Session.
Okay.
So important methods. Sure. Yeah. So important methods are get message, print, stack trace, and toString. We have discussed. We already discussed these three methods. It will give the description. This will completely print the stack trace. That is sequence of method executions or method calls. Okay, and then toString. We have already seen. You can either override this toString method for the exceptions that you yourself create for applications or application specific exceptions that you create. Right? You can override this to print meaningful messages. Print meaningful messages. Okay, meaningful messages. So whenever you use a particular object, say for example, not found, data not found exception, right? You can override in this particular class. So whenever that exception is used in print line statement or along with your string, this toString method will be called, and the respective thing will be printed along with the string that you attached here. Okay. So that is the useful methods. And then let's move on to the next one. So yeah, as we mentioned, the two most important are your exception and the exception strings. There are something called as chained exceptions. Okay, you read about this chained exceptions and try experimenting with this chained exceptions. Okay, so with this chained exception, it is nothing but chain. You have one exception, you chain that exception with another exception. Okay, so that is what is this chained exception, and for this chaining exceptions, it is nothing but your chains, right? One exception, two exception, three exception. You're chaining them together. Okay, that is why they are called as chained exceptions. And after introducing this was introduced in from JDK 1.4, and after that introduction, two more constructors were added. That is throwable, which throws, which takes a throwable object, and another throwable, which takes string and throwable object. Okay, based on these two things, two methods were added: get clause, get cause, and init cause. Okay, init cause. So if you want to, like, say for example, you are trying to read from database. Okay, you don't get data from the database. So you have application specific exception, data not found exception. Okay, so that is thrown. Okay, so because data is not found, you are trying to do some arithmetic exception, no, arithmetic operation. Say whatever the data that you read from your database, you are using that for dividing some number. Okay, so the data found from database. Data found from database. So you are storing that in some variable I. Okay, since we don't find, for some cases we don't find the database, I mean the data. In such cases we initialize the data to 0, and here we get arithmetic exception. Okay, so what exactly happens in such scenarios? Arithmetic exception will be printed in your output. You see that this there is an arithmetic exception. Okay, and it prints where exactly your exception has occurred, this particular line of code. But when you see this code, you still think that it is arithmetic exception only, because you are assuming you got the data from database. Okay, you assume that you got the data from database, but actually what is causing the this arithmetic exception? Data not found exception. Okay, so data not found exception is the root cause of your arithmetic exception, this exception, right? Normal circumstances, when we get the data, this gets executed properly and we will not see arithmetic exception at all, right? In such cases, what you can do, you can attach arithmetic exception with not found exception, data not found exception. Okay, data not found exception. Okay, to make sure that this is the root cause, and you can how you can do that. So you have try catch block. Try catch block. Here you have mentioned arithmetic exception. Okay, and you are throwing the arithmetic catching arithmetic exception here. You mention arithmetic exception here, and then attach that exception. Say for example, let me try it in a better way. Write it in a better way. So what is happening? I have try block. Okay, I have try block, and then I am doing int I is equal to 20 divided by data obtained from database. This is the data which is obtained from database. Okay, and then I will catch. I think this is like there is a possibility of arithmetic exception. I will catch that arithmetic exception. Arithmetic exception. Okay. So here, whenever this exception happens, like say data is not found, and whenever data is not found, I am initializing j to 0. Whenever data is not found. Okay. Whenever data is not found, I am initializing it to 0. So you are querying the database, and you are not getting the data, and j becomes 0. In such case, arithmetic exception is thrown, right? And that arithmetic exception is caught here. So when normally when you are trying to print it, it will show arithmetic exception. Arithmetic exception. Okay. So in such scenarios, we think that okay, we are this particular piece of code is causing exception, and we assume that we got the data. Assume that we are assuming we got the data for j, and we will not be able to figure out why this exception is causing. So in such scenarios, here itself what we can do is we can use this particular method. What we can do, e dot initialize cause, and then you can mention the object itself, new data not found exception. Okay, so in such case, what exactly happens is the arithmetic exception is caught. You are not sure what exactly is happening. Then you can use this particular method, get cause. Okay, so whenever you are catching, you can say like whoever is catching this. Okay, so get cause. That will print the actual root cause of the exception. Actual root cause of the exception. Then we can clearly figure out why that arithmetic exception has happened. Okay, so now we know after this get clause, we will know that it is because of data not found exception. Okay, so I have one example, but I don't want to show that example. Okay, so you just try that example. Okay, like whatever we discussed just now, just try that example and see if you are able to kind of like simulate this chained exception. Okay. So that's the end of this session. If anyone has any questions or if anyone needs any clarification, please let me know. We can discuss. Otherwise, we can wind up this call. Okay. Please let me know anyone has questions. Okay. Yeah. Thanks, Kavita. Okay. Let us wind up this session, and we'll meet tomorrow at 8:30 as usual. Okay. We'll start a new topic, that is enumerations, and we'll try to cover enumerations and boxing, auto boxing. If time permits, we will try to cover annotations as well. Okay. Thanks everyone. Have a great evening. Enjoy your evening. Bye.